Hey you guys, Professor Vitt, and welcome to the lecture for Chapter 4 on logic. Now, generally speaking, there are parts of our book that I like a lot. The chapter on logic needs a little bit of brushing up. So for purposes of this next coming exam, I want you to pay attention to this lecture, and that should help you get through some of what you're being asked to do on that exam. But still, his book is very helpful. So how are we going to approach Chapter 4? We're going to talk about what logic is. We're going to talk about types of arguments found in logic. Then we're going to look at the features of the various types of arguments that we have. In other words, there are two kinds of arguments here. We're going to look at features that belong to both of those two kinds, or rather, that belong to one set of inductive reasoning and one set of deductive reasoning. And then we're going to look at unfounded assertions, and then we'll talk briefly about contradictions, but we won't spend a lot of time doing that. So this is the roadmap for the lecture 1, 2, 3, and 4. Some of this material will go by pretty quickly, so you may need to rewind. It's not unusual if you need to. So let's go ahead and start. Logic is the study of argumentation. Now, when I say argumentation, I mean something real specific. I don't mean two people yelling at each other, two people arguing about something, and somebody sleeping on the couch. Instead, an argument is a technical term, and what it means is there are a set of premises, which are really like statements, and these premises, when you take them together, they support a conclusion. So let me give you an example. When I was a teenager in high school, I really wanted to go to this party, and my folks said, no, you can't go to this party. And if I wanted to, we had an argument about it in terms of fighting, but if I wanted to be rational and I wanted to clarify the issue, I would have presented an argument like this. And by argument, I mean a set of premises which guarantee a conclusion, or at least support it. So this is what it would look like. My folks would say, no, you're not going to the party. And I would say, well, everyone is going to the party. I am an everyone, thus I should go to the party. Now notice here that what I'm trying to do is I'm trying to get them to accept that 1 and 2 support 3. It's not a question of just yelling at someone. It's a question of an argument having a certain structure. If you have the right structure, then that makes your point more forceful. It carries more weight. Okay, there are two types of arguments that we're going to consider: inductive arguments and deductive arguments, or induction and deduction. I'll use the adjective and the noun sort of interchangeably there. Let's look at deduction first. Now, the book says of deduction that as long as you accept the premise, the conclusion necessarily follows. Yeah, that's fine. That's okay. That's a good way to think about it. But you can be a little more precise, and you can say it's impossible for the conclusion to be false if the premises are true. So that's different than induction, where the premises support, but they don't guarantee the conclusion. So a quick little trick here to remember. Induction is one where the premises support the conclusion. Deduction is when they guarantee the conclusion. Let me give you an example of that. So let's take this first argument up here in white. Professor Vitt wears blue on Tuesday. That's a premise. And then our conclusion is, thus, Professor Vitt will wear blue on Wednesday. The question is, if 1 is a premise and 2 is a conclusion, is this argument deductive or inductive? Well, in order to answer that question, we need to explain what the relationship is between 1 and 2. If 1 guarantees that 2 is true, then the argument will be deductive. In other words, if 1 is true and 2 must also be true, then the argument is deductive. But if 1 just supports 2, then it's going to be inductive, right? So suppose I wear blue on Tuesday, and that then strengthens the case that I'll wear blue again on Wednesday. That's because I'm a creature of habit or something like that. Well, that would be a case where the first premise helps to support 2, but it doesn't guarantee it, right? I could wear blue on Tuesday and then red on Wednesday. There's nothing about me wearing blue on Tuesday that guarantees that I'm going to be wearing blue on Wednesday, but it might support it if I'm a creature of habit or something like that. In that case, that would be an inductive argument, right? Because 1 would support 2, but it doesn't guarantee it. let's contrast that with the argument in red here, which says, if Professor Vitt wears blue, then he is wearing a color. Professor Vitt wears blue, thus Professor Vitt is wearing a color. Notice here that if 1 is 2 and 2 is true, then 3 must also be true. It's forced to be true. And that's the hallmark of a deductive argument, because the support relationship between the premises and the conclusion is absolute. In other words, 1 and 2 force 3 to be true. All right. Now we're going to look at some, so I told you quick transitions here. Now we're going to look at some features of reasoning, and these features belong to either inductive or deductive reasoning. So let's clarify first deductive reasoning. One of the most important traits of a deductive argument is validity, or an argument being valid. An argument is valid if it's not possible for the premises to be true and the conclusion to be false. So let me give you an example of a valid argument. If Jerome is in Long Beach, then he is in California. Jerome is in Long Beach, thus Jerome is in California. So this is Long Beach, this is California. If Jerome is here, then he has to be inside of California, right? It is a total necessity. There's no other way it can be true, in which case that would be a valid argument, right? Because 1 and 2 guarantee 3 is true. Now, let's look at soundness. Soundness is when an argument is valid and the premises are actually true. So if we looked back on this case involving Jerome, although this argument is valid, if I was going to ask you whether or not this argument is sound, I would say, well, is Jerome actually in Long Beach right now? Or is he visiting, his friend in Nevada or something like that? If he's not actually in Long Beach, then this is not a sound argument. It may still be valid, because valid says, look, if the premises are true, does the conclusion follow? But a sound argument says the argument is valid and the premises have to actually be true. So that's the difference between validity and soundness, right? Okay, let's go here. Let's give a couple of examples. Okay. This example is taken from a famous UFO sighting that takes place in Arizona in the 90s. It's famous. It's called the Phoenix Lights. This is a contemporary rendering of the Phoenix Lights. It was seen for a period of hours by hundreds of people. One of probably the most celebrated witness to this event was the governor of the state, Fife Symington. And Fife Symington has come on. You could Google his name and put UFO after it. You'll find all kinds of interviews where he talks about it. But I'm just going to use this as a backdrop to talk about validity and soundness, okay? So, Fife Symington saw this UFO and then later made a joke about it at a press conference. But let's just forget about that. We have two premises and a conclusion. So we have one thing that we're trying to prove, that's the conclusion, that's number 3, and then we have 2 reasons to support it. I'm going to ask you whether or not this is valid and whether or not it's sound. Okay, premise number 1. Fife Symington is either lying about seeing a UFO or he's committing fraud. Fife Symington is not lying about seeing a UFO, right? Thus, Fife Symington is committing fraud. All right, so how does this work? Okay, so I'm going to use this next example for of validity and soundness to talk about. Let's use some examples of validity and soundness to give you a feel for how you'd be tested on this. Dang it. All right. So let's look at an example involving a UFO that lots of people saw, an unidentified object, flying object in Arizona in the 90s. Just a quick backstory. This is a contemporary drawing of the object. It was seen for 106 minutes around Phoenix, Arizona, but for much longer, for other periods of time, apparently. Now, this is a famous sighting because it was seen by hundreds of people for a long period of time, and the most famous witness to this UFO was the governor of the state. His name is Fife Symington. Kind of a strange name, but it's actually his name. And he was convinced that it was authentic. He actually, if you Google his name and you look under UFO, he thinks it was a real UFO, something from another planet. So I'm going to just use that context to demonstrate validity and soundness. Okay, so let's talk about this. Fife Symington, remember he's the guy who saw the UFO, is either crazy because he saw the UFO or he's lying. He's committing fraud, right? Now, he's the governor of the state, and so it would be hard to achieve that position if he was truly crazy. It would be very difficult for him to get, financial endorsements for his campaign and so forth. It would be difficult to have the requisite know-how to conduct himself in that office if he was clinically insane. So someone would argue, well, he's not crazy, so he's committing fraud, right? In other words, he's either crazy or he's willfully lying, right? Well, he's not crazy because he was the governor, so he must be committing fraud, right? So I have the way that this argument looks is I have option A or option B. Option A is not going to work, so it's got to be option B. And the question is this argument valid? In other words, if I believe that 1 is true and 2 is true, does 3 have to follow? Well, yeah, it's valid. This argument is valid. I have option A or B. If I assume that option A is not correct, then B has to follow because I only have 2 options, right? So that would be a valid argument. If 1 and 2 are true, then 3 has to also be true. Now, I'm going to ask you about soundness. Do you think this argument is sound? In other words, are these premises 1 and 2 actually true? And so we will agree that if they're true, then they would guarantee 3, but are they actually true? Well, I've never met the person, but I would argue that Fife Symington is probably not crazy, so that's probably correct. But 1 is not exactly right. And the reason why 1 is not right is because it assumes he's either crazy or he's committing fraud. But those are not the only 2 options, right? He could be mistaken, right? I mean, just because you see something extraordinary, maybe you see a UFO in the sky, it doesn't mean you're crazy or you're committing fraud, right? It just means you saw a light in the sky. Maybe you're mistaken about what it is. So this argument would be valid, but it's not sound because premise 1 is false. It's not the case that he's either just crazy or committing fraud. It should be he's either crazy, he's committing fraud, or he's mistaken, right? Then that would be better. But as it stands, although this is a valid argument, it's not a sound one. And it's not a sound argument because premise 1 is false. And premise 1 is false because those aren't the only 2 options, right? Okay, so it's valid but not sound. All right, let's look at this next one. If Bigfoot does not exist, then all the footprints are hoaxes. Bigfoot does not exist, right? Thus, all the footprints are hoaxes. Now, this should look a lot to you like the Jerome and Long Beach example. And that's because it's a famous argument form, if then. It's called modus ponens. You don't need to know that. But the question is this argument sound? It is valid because if 1 and 2 are true, then 3 would have to follow. In other words, if Bigfoot really didn't exist, then all the footprints are hoaxes. Bigfoot does not exist, so all the footprints are hoaxes. In other words, if 1 and 2 are true, then 3 would have to follow. But again, when you ask if an argument is sound, you're asking whether or not the premises are actually true. And is 1 actually true? Well, it turns out no. If Bigfoot does not exist, then all the footprints of Bigfoots are not necessarily hoaxes. And that's because sometimes when a bear moves through terrain, it can produce an odd footprint. And that footprint can be mistaken for something like a human print. Now, it doesn't happen often, but it's certainly possible. So one is not true, because even if Bigfoot doesn't exist, it doesn't mean that all the footprints are hoaxes. They're just mistaken identification, right? Someone thinks it's a Bigfoot print, but it's not. It could very well be a bear. So this is a valid argument, but it's not sound, and it's not sound because one is false, because one is not actually true. Even if Bigfoot doesn't exist, it doesn't follow that all the footprints are hoaxes. Someone could have just taken a cast of a Bigfoot print, and it turns out that they were mistaken. It's not a Bigfoot print. Okay, so let's move on here. Now, the book doesn't talk about this, but I'm just going to mention it. You won't be tested on it. There are lots of different kinds of induction. There's argument by analogy, there's generalization, there's appeal to authority, there's argument by sign, and argument by prediction for inductive argument. Just know that there are lots of different kinds of induction, and they do different things. Okay, we talked about soundness, so let's do another re-up on that, just to review the examples that we've done. Here's an example. Oh, argument. I love it, right? Example of a sound argument. That's obviously intended to be a G. Okay, a sound argument is one where you have a valid argument and all true premises. So this is an unequivocal answer of example of a sound argument. All flowers are plants, all daisies are flowers, therefore all daisies are plants. In other words, if these two claims are true, then 3 has to be true, right? Because all flowers are plants, all daisies are flowers, so all daisies would have to be plants. And that's correct. In other words, if these two things are true, then the conclusion has to follow. And it turns out that these two things are actually true. The premises are actually true. All flowers are plants and all daisies are flowers. Okay, now we're going to get to strong arguments or strength. And this is a feature of inductive argumentation. And that's when a strong argument is one when the conclusion probably follows. In other words, the conclusion is supported greater than 50%. In other words, the premises make it more likely than not that the conclusion follows. So it's not 100%, it just makes it more likely. A weak inductive argument is one where the conclusion probably does not follow. It's less likely to follow from the premises, so it's less than 50%. And then you have a cogent argument. A cogent argument is really just kind of the inductive form of soundness. In other words, you have a strong argument and all your premises are true. Let me give you a quick example of that. Every previous U.S. president was older than 40, therefore probably the next U.S. president will be older than 40. So this is a strong argument, and it's also containing true premises. Okay. All right, so there's just a wrap up of cogency. Okay, now we're going to move to the final. By the way, don't anticipate being tested real heavily on strength and weakness and cogency. Just a tip. Okay, unfounded assertions and contradictions. Here we are. Often when you are trying to employ logic in the application of critical thinking, you have to sort of repeatedly ask yourself, has this claim that the person is making been sufficiently demonstrated? And much of the time, the answer will probably be no. In other words, they're making a claim, but that claim has no foundation, right? There's no support for it. So let me give an example. There's a famous Japanese figure. He's not alive anymore, but he made this sort of miraculous claim that words affect matter and affect nature. So he claims, this is a quote from one of his writings, beautiful words create beautiful nature, ugly words create ugly nature. And this is most commonly seen in, he applies this theory to ice crystals, and he feels that if you somehow speak nicely to ice crystals when they're forming, then they will form beautiful patterns. But if you are negative and you try to freeze those ice crystals, then they won't look as pretty. They won't be symmetrical. They'll be corrupted. They'll look ugly. Now, it turns out that this is an unfounded assertion, just like this, right? Just saying beautiful words create beautiful nature. Well, that's a claim, but you haven't demonstrated it, right? So, in other words, he hasn't, it's an unfounded assertion because he's just making the assertion. The question is not whether you've made the assertion, but what evidence you have to make something, what evidence you have to believe that something is true. It turns out that this assertion is pretty unfounded because we know that there are other factors that affect the formation of crystals: humidity, temperature, pressure, and so forth. These things these things affect the formation of crystals. And controlled experiments, to the extent that they've been done on ice crystals and so forth, do not demonstrate the psychic powers are very often a claim made that is unfounded. Well, I should clarify. Oftentimes people will say, gosh, I was thinking of John and the phone rang and it was John, so I must be psychic. Well, you haven't demonstrated that. All you've demonstrated is you were thinking of John and he called, but you haven't demonstrated that your thought concerning John actually caused him to call, right? Do you notice the difference there? Just because you have noticed two events close to one another in time doesn't mean that one caused the other. So if you claim there's a psychic power here, then you have, in fact, you've made a claim that is not founded. Now, we'll go into psychic powers later, but that's the general idea. Okay. Just a brief point here on contradictions. They're very similar to reductios. And the general idea here is if you can get someone trapped in a contradiction, then there must be something wrong with their theory, because a theory can't be both true and false in the same time in the same way. Okay, you guys, that covers it for logic. You should have enough now to take your exam, provided you've read the book and so forth and you've studied up. Okay, good luck.